Okay, ladies and gentlemen, as we continue section 2.4, same question. If I had these functions, and I'm putting y equals, if I had the function y equals 1/2 times the absolute value of x minus 2. Alright, the absolute value of x has the shape of a v. That's the basic shape of a v, starting at the origin and going up. The minus 2 tells me that I'm going to drop the whole graph down 2 blocks because that's the y value. It's not in with the x, so we know it's y. And the 1/2 in front means that the graph is going to go up on the y-axis half as fast as it used to, which basically means what we've done with it is we've compressed it. And if you describe what's happened to its branches, they've gotten wider. So what's happening in this problem is we have the basic V shape. We have moved it down 2 units. That's what the minus 2 does. We have, let's see. Oh, that's pretty much it. The V shape has been moved down 2 units and it's been compressed. And basically when I say it's been compressed, what's happening is the branches are looking wider. You know, it looks like the original function is wider. I mean, this new function is wider than the original. It's a wider opening V. Okay? And that's going to happen anytime the number in front here is something between 0 and 1. If it were bigger than 1, it would be like up in the last thing that I did, where it would be a stretching and the branches would actually get closer together. Okay, y equals, let's see, the opposite of the square root of x. Now, if you recall from your library of functions, the square root of x is in quadrant 1, and it looks like that. It's sort of the upper half of a parabola. When I'm multiplying it by negative, Zeus, hush! When I'm multiplying it by negative, I'm changing these y values from positive to negative, so what's happening is it's going to look like this. And the best way to describe that is a reflection with respect to the x-axis. Okay? Anytime you have a function and you multiply it by -1. Okay, let's look back at our old video. When you have f of x and you multiply by -1 and that becomes the opposite of f of x, you're reflecting the graph with respect to the x-axis. Think about why that makes sense. If a y value used to be positive, when you multiply -1, it makes it negative. It's crossing the x-axis. Okay, now, in this next graph, y equals the square root of the opposite of x. This time the x value is being multiplied by -1. Well, picture what happens. If you had an ordered pair in quadrant 1, and you multiplied the x value by -1, you would be crossing the y-axis. So this time, this is going to be a reflection, but it's going to be with respect to the y-axis. So, if my original graph was in quadrant 1, which it was, that's what the square root graph looks like. If I reflect it with respect to the y-axis, it is now in quadrant 2. Okay, we just kind of reflected it, we flipped it over, and that's what the graph now looks like. So, basically what you need to remember is this. If you have f of x and you change it to the opposite of f of x, you're reflecting with respect to the x-axis. And if you have f of x, and from that you want to graph f of the opposite of x, in other words, you're multiplying the x value by -1, you're reflecting with respect to the y-axis. Okay, and let's see. We have the function y equals the square root of x plus 2. Now, the square root of x, and then the plus 2 is on the outside. If that plus 2 is not with the x, that plus 2 is with the y. So what that means we're doing is we're taking my original graph, which remember used to be in quadrant 1, and we're moving it up 2 units. So what's that doing? Instead of starting it at 0, it's starting it at 0, 2, and then of course it has the same basic shape. So the plus 2 not being under the radical meant the plus 2 didn't involve the x. Well, the only other thing it could involve then is the y. And if you're adding 2 to a function, you're moving the entire graph of that function up, in that case 2 blocks. If you were subtracting 2, you would be moving the entire graph down 2 blocks. Okay? Remember, a y value moves up or down on the graph. An x value, on the other hand, is what's happening here. Notice that the plus 2 this time is under the radical with the x. And remember what happens. When something happens to an x value, what happens does it backwards. So if I say x plus 2, I'm really moving the original graph 2 to the left. And remember kind of a quick way I taught you to remember that. What makes x plus 2 into 0? Negative 2. So kind of think of that as 2 to the left. So my new graph would not be starting at 0, 0. It would be starting at negative 2, 0 and keep the same basic shape. And we're done.